In this video, we solved problem 8.3.063 from the Larson and Edwards Calculus Early Transcendental Functions text, 7th edition. We're asked to evaluate the definite integral, the integral from 0 to pi over 2 of cosine of t divided by the quantity 18 plus sine of t with respect to t. It's actually not too bad at all, even though it looks much worse than it is. In this case, though, I wouldn't use the guidelines that are associated with powers of sine and cosine, because we've got something a little different here. We've got this expression involving sine of t in the denominator and a cosine of t in the numerator. So it's certainly a trigonometric integral, but it's not any of those types that we previously talked about. It doesn't have cosine to some power times sine to some power where the angles are the same. So what I would do instead is say, do basic rules apply? And they don't. We don't have any quotients in our basic rules. And then I would say to myself, does u-substitution apply? And yes, if u is sine of t, then du would be cosine of t dt. So we can write everything up here entirely in terms of u pretty easily. But let's do it even better. If I take u to be the entire denominator, it will simplify our work even more because the derivative of that 18 is 0. So if this is u, the derivative is still cosine of t dt, and we end up with a 1 over u du. And that's going to be a really simple integral to evaluate. So rather than letting u equal sine of t, which will work, you'd have to do a double u substitution, like you'd have to do it twice. Let's let u be the whole denominator. And generally, if there's a constant there, you want to include that in your u, because the derivative of the constant is 0 and it's not going to affect anything, except it's going to make your integral a lot simpler. If u is 18 sine of t, du is still 0 plus cosine of t times dt, and everything up here can be written entirely in terms of u. So we've chosen our u, and then this is du, and we end up with an integral that looks like this. We've got 1 over u, because that u is in the denominator, and cosine of t dt is du. Now, in order to get appropriate bounds over here, we've got to replace t with 0 and replace t with pi over 2. These are bounds for t. These are t values. When I write the integral in terms of u, the bounds need to be u values, otherwise they're not actually equal to each other. So it's pretty easy. All you do is take the t values and you substitute them into your equation for u. So to get my new upper bound, I use my old upper bound. To get my new lower bound, I use my old lower bound. You can call these bounds. You can call them limits of integration, same thing. Okay. 18 plus sine of pi over 2 can be simplified. Now, if you don't remember, sine looks like this. It repeats every 2 pi in both directions infinitely. And all the interesting things happen at 1/4 of the period. So after 2 pi, it starts again, but it goes to a maximum of 1 at 1/4 of the period, which is pi over 2. Then it goes back to 0 at pi. Then it goes to its minimum value of -1 at 3 pi over 2, and then it goes back to 2 pi. So that's where we're at. So sine of pi over 2 is actually just right there. It's just the y value on that graph, which is 1. So we have 18 plus 1, which is 19, and then 18 plus 0, which is 18. So this is just the integral from 18 to 19 of 1 over u du. And that's pretty simple. Now, because we've back substituted, or excuse me, not back substituted, because we've substituted, because we got new bounds for u, we never have to back substitute. We're just going to evaluate this integral and be done. So we'll take the antiderivative. The antiderivative of 1 over u is the natural log of the absolute value of u. You plug in the upper bound and lower bound and subtract. Absolute value of 19 is 19. Absolute value of 18 is 18, so you could leave it that way. It's probably not the way Webassign wants it, though. there is an identity from algebra class. Log of A minus log of B is log of A over B. So this is actually log of 19 over 18. So this is the right answer. That would be fine for a test or a quiz. But that is probably the answer that WebAssign wants.